Hello everyone, and thank you for this opportunity to present online this time. I will be presenting my talk on experiences and challenges connected with the road lighting quality verification. My name is Miko Przybyła. I'm the head of Optic. We are a light quality control company providing instrumentation and software to verify quality of lighting. In this talk, I am also presenting the results of the cooperation with Poznań University of Technology, because we have been involved with the university in the development project to come up with a solution for improved road lighting quality. So in this presentation, we are going to focus on luminance distribution measurements, because this is now being discussed a lot for several reasons. Obviously, we know that there are a lot of modern LED-based systems being installed all over Europe, because this is allowing for significant energy savings. And this is also an opportunity to improve lighting conditions on the roads where the lamps or luminaires are replaced with new ones. In any case, these are the major objectives, and that's why cities and local governments, municipalities are investing in modern LED lighting. We know, on the other hand, that there are some questions or some hesitations how to control the quality of this installation. And we know that there is a lot of work which is done usually before the investment stage. So initially, when there is a design stage and the specification for tender, a lot of people are involved in the process, and there is a lot of effort put in this initial stage. Unfortunately, when the installation is ready, the compliance testing or the control whether the actual installation is conforming the design requirements or the standards, this is not very often made. Usually the quality control of the installation is done quickly. Sometimes it's only a matter of inspecting the number of luminaires and the paperwork, but performance parameters are very seldom controlled on site. There are reasons for this, and this is part of this discussion that we are facing now, why people are not checking quality on site, and if there are ways to improve it, and what are the tools that we can use for that. Sometimes also the quality of the new installation is not what local citizens are expecting. Sometimes LED lighting is just criticized only because it's new, and we have limited possibilities to verify this in some kind of unbiased way. So in this presentation, I would like to share some experiences and also tell you more about the available tools. And also we will discuss what are the standards that we can use to verify this in this unbiased way. We have an existing road lighting standard in Europe. The recent publication was in 2016, and it is consisting of 5 parts. There are guidelines where we can find important information about the selection of lighting classes. And this is important because we have to use these lighting classes for the design stage. So the designer is deciding how many luminaires of what kind of luminaires are going to be used with a specific distribution to meet the requirements of the standard. But the same lighting classes are then influencing the methods to verify the quality of the installation. The second part is describing performance requirements. Then we have calculation methods described. And in part 4, we have methods of measuring lighting performance, and this is corresponding to the lighting class that was selected by the designer, basically. And then last but not least, the energy performance indicators. The major drive for LED luminaires on the roads is the energy saving, so we have to pay attention to this last part as well. In my presentation, I'm going to focus on lighting classes selection and also methods how to measure the lighting performance. So we have to consider which roads we can verify with the use of luminance distribution method. And this standard clearly indicates how we should handle that. So for the design as well as for quality verification, so for the measurement stage, we should be focusing on luminance method for M-class roads. M stands for motorways. So obviously we are talking about the roads with medium and high speeds. This is connected with performance characteristics and also visual perception of the driver. On the roads where we have higher, medium or high speeds, we need basically more light. So the luminance level requirements are higher for M-class roads. Now that we know how to select the road classes, which is directly indicated in the standard, now we can discuss how to perform the measurements correctly. Because in the standard, we have a table indicating luminance levels. So we have 6 road classes. And we have, for each class, we have average luminance and the uniformity of luminance indicated. In the standard, you can find also methods how to calculate this uniformity factors. As you can see, the M1, these are the higher speed classes, where you can see clearly that 2 candela per meter square is the minimum luminance level, and then uniformity is also described in the column next to that. Then going down, we have slower and slower speeds, let's say. So we have lower and lower luminance levels indicated in the standards, and these are minimum luminance levels that we have to meet. And now how we can control whether this uniformity factor is achieved or not? Well, there is no other way. We have to go on the road. We have to make measurements and we have to make our calculations. So as you can see here on the photo in the background, this is the typical situation on the road. We have a motorway with 3 lanes. And for each lane, there is a specific method described in the standard how to apply measurement point grid. This is corresponding to the design stage where we're designing and deciding how many luminaires are going to be used, and the calculation software, this design software, using the same methodology. And now after the installation is designed and delivered, we are on the road again to verify using the same points to verify the uniformity of luminance and check whether there is a minimum luminance level delivered to the road. This is this this is the drawing from the standard, giving you an idea how to position the measurement points. So as you can see, for each driving lane, we have an area of a lot of points in a specific location and the distance between each other. And this is allowing us to check the luminance level and also check the luminance uniformity. Positioning of the meter is also very critical in this case, because the luminance meter should be placed at the height of 1.5 meter above the road level. This is equivalent of the driver's sight level of the eye of the driving person, because luminance is used here as a performance parameter to check how we can observe the road surface and whether the driver is able to see the objects on the road properly or not. So the luminance is important quantity here, because we are talking about the observation of the road luminance, as if the driver was seeing the same measurement in the same area. The average luminance should be measured for the whole roadway for each position. So if you have 3-lane road, you need to position your measurement device 3 times in the different locations. And for each position, you have to make the measurements of the whole road. From the driver's perspective, the area between 60 and 160 meters in front of the vehicle is important. So you can imagine that this is quite a large distance that we are observing, and the same distance should be observed by the measurement device. So the meter should be positioned in each center of the lane, one by one. To take a closer look at how it looks like on the road, you can see this drawing here. So you can see that the meter is positioned above the road surface at 1.5 meter. The distance, 60 meters, is minimum between the first lighting pole or the luminaire in the measurement field, and we are capturing the area between 2 successive poles. As you can see, the location of the measurement points, so the grid is located according to the standard, and this is for 1 lane only. But this is just now nice looking picture or a drawing. In reality, from the driver's perspective, the measurement points density is increasing because we are quite far from this area. So in fact, if we are supposed to measure each point individually, one by one, this task is becoming a very difficult. And this is where we are discussing first biggest obstacle to make more measurements on the road, because how to do that, this is the biggest question. There is a very large number of measurement points. This is required to check the luminance uniformity. This is becoming a very difficult task. Some of the points may be overlapping in a larger distance, and the targeting or positioning of the meter is a very challenging task. So this was the trigger for our project together with Poznań University of Technology to design and to come up eventually with advanced but easy to use luminance meter to promote more measurements on the road and to allow more stakeholders to verify the performance of the lighting on the road. The project was developed and co-financed by European Union It was in the framework of National Center for Research and Development. And we selected Poznań University of Technology to partner with us in this project because they have a long-lasting experience in road luminance measurements. And they also have a lot of experience using different type of luminance measuring devices. In the project, a new model of an imaging luminance measurement device has been developed. The research and development and industrial research stage was in partnership with the University of Technology. So we had a chance to verify our engineering work against their scientific knowledge in this field. And this allowed us to come up with a new design and a completely new approach to the luminance measuring devices. Obviously, we are using luminance measuring device, so imaging system, which has been existing on the market for a number of years. But the important point is to have it modified to the specific task on the road. Majority of existing systems are laboratory equipment, and they are just carried out on the road to make measurements. But there is little chance that you will be able to do it quickly. So usually you spend a lot of time out there during the night because we are talking about lighting. So you need to have everything you need with you on site to make precise testing. So the imaging luminance device that is designed as a part of this project is compliant with the European standard, allowing to make a quick measurements of the road luminance. And the software which is supporting this measuring unit is calculating overall uniformity, also calculating the minimum required luminance levels. The device itself is prepared for the work outside. So this is completely different approach than the typical laboratory instrumentation. So there is a waterproof housing. There is additional power source which can be used on the road because obviously it's a field work. So this has to be quite self-contained system. The sensor is stabilized thermally using Peltier cooling system to allow for precise measurement regardless of the conditions outside, because Europe is quite large and there are countries measuring during summer, there are countries measuring during fierce winter conditions, and we are talking about absolute luminance levels. So this was critical part of the project to deliver thermally stabilized system. There are also peripheral devices like markers to indicate the measurement field, and tripod and transportation case that you can carry it outside without the risk of damaging the equipment. So the system features the imaging luminance measuring device, typical field application tripod. There is also measurement wheel to measure distances and locate the measurement field precisely. There is transportation case, and last but not least, there is a dedicated laptop with software supporting the measurement process. Now, coming back to the requirements, we are supposed to check the luminance levels depending on the class, but to do that, we have to make this number of measurements. So how this new system is helping you to do that is shown now in the next slides. The dedicated software is allowing you to capture the field according to the standard. So as you can see, from the perspective required by the standard, the measurement field view is very specific and it's quite small. So the software is going to help us to change the viewing angle to have like a helicopter view on the measurement field to help us to position the measurement points. And then the measurement points are applied automatically by the software in the measurement field which is required. So as you can see, there is a significant number of points in this instance, and for each point we are measuring luminance level, and this is also helping us to make a calculation of luminance uniformity. As you can see here, there are 3 lines, so there are 3 lines for each driving lane, and specific number of columns depending on the size of the measurement field. And in each position of this matrix, you can see the luminance readings. These are actual calibrated data obtained from the luminance measurement. Using this, applying the minimum and maximum luminance levels and the uniformity required for the specific road class, we can check quickly whether the average luminance, overall uniformity, and line uniformity is meeting the requirement of the standard. So at the end of the day, when we have the measurement made, the software is helping us to calculate the values and automatically confirm this according to the standard. So what we have learned today is that the road lighting quality verification can be done according to the European standard, road lighting standard, and using luminance method is allowed for M-class roads. On-site measurements should be made more often to allow us to check the quality of installation and also check the maintenance parameters of the lighting installation. And eventually we can say that after 2 years of this project together with Poznań University of Technology, we are sure that the imaging luminance measuring devices are simplifying significantly the measurement process, and hopefully this will increase the light quality control on the illuminated roads in Europe. So this is it from my side. Thank you very much for your attention. I hope this was useful and informative for you. If you have questions, of course, we are here to answer. Please share your thoughts and questions, and I'll be happy to answer them. Thank you very much.